In this video, we are going to be looking at a question that involves some calculus, but in the context of mechanics. So, I know people have asked for this video, and they've mentioned something along the lines of, it's not the maths that's hard, it's knowing what to do with it, which is a fair point. They go, I get the maths, but I don't know how to do it. I don't know where to start. So I thought I'd go through some of these kind of questions. And if people have other recommendations or any questions they want answering, let me know and I can see what I can do. So a particle moves along a straight line through an origin, O. Initially, the particle is at O. So just pay attention to that. We're going to need it later on. I'll tell you when we need it. At time t seconds, its displacement from O is x meters and its velocity, v meters per second, is given by v equals 24 minus 18t plus 3t squared. And we want to find the times t1 and t2 at which the particle is stationary. Okay, so to do this question, we're considering when the velocity is equal to 0, because that's what it means for it to be stationary, not moving. All right, so stationary, let me just write that for part 1. Stationary just means that the velocity equals 0. That's all that means. Okay, so if we know that the velocity is equal to 0, well, we've got an expression for the velocity. It's this thing here. So that means that 24 minus 18t plus 3t squared equals 0. Now, I don't know about you guys, but I want to rewrite this in the way that, we're kind of used to seeing quadratics, because we've got a quadratic which we need to solve. So I'm going to rewrite it as 3t squared minus 18t plus 24 equals 0. Now, that looks much nicer to look at. When something is good to look at, it makes it easier to work with. Okay, we notice here that there's 3, 18, and 24, which are all divisible by 3, so we can make our lives a bit easier. Dividing by 3 gives us t squared minus 6t, not 60, but 6t plus 8, which equals 0. Can we factorize this? Yes, we can. So this can be factorized into 2 brackets, t minus 4, t minus 2. Minus 4 times minus 2 is positive 8. Minus 4 minus 2 gives you 6. Equals 0. So therefore, t equals 2 or t equals 4. So just to fully answer the question, they've asked us to call it times t1 and t2, where t2 is bigger than t1 or is greater than t1. So we take t1 as the smaller value. So therefore t1 is equal to 2 and t2 is equal to 4, which, that's all good. Okay, next question. Find an expression for x at time t seconds. Well, x represents the displacement. It says the displacement from O is x meters. So I'm just going to put this little relationship in case people don't know. And that's this little relationship. So we've got, in fact, let me go a bit higher. I'll come back to the question so you guys will be able to see it. But if we go from so I'm going to relate displacement velocity and acceleration. So by definition, velocity is the change in displacement with respect to time. So to go from displacement to velocity, we differentiate. And again, by definition, acceleration is the change in velocity with respect to time. So to go from velocity to acceleration, we differentiate. Now going backwards, of course, if we want to undo the differentiation, go from acceleration back to velocity, well, we do the opposite of differentiation. We integrate. And the same thing, to undo the velocity, i.e. go back to displacement, or undo the differentiation that got us the velocity, we need to integrate. So just a bit of housekeeping there. Cool. All right, and we're trying to go from velocity to displacement, so we know we're going to need to integrate. So we've got the function 24 minus 18t plus 3t squared. So v equals 24. Let me just check again, because I know I'm one of those people who forgets. 24 minus 18t plus 3t squared. 24 minus 18t plus 3t squared. Please, let me just do a sanity check, because I'm not really trying to make mistakes here. 24 minus 18t plus 3t squared. Okay, cool. All right. So then x is going to be the integral, right? The integral of v with respect to t. So that's the integral of this expression here, 24 minus 18t plus 3t squared dt. It's good to put the dt or d whatever, just to just so we can remind ourselves of what we're integrating with respect to. Okay, then when we integrate this, we get 24t minus 18t squared over 2 plus 3t cubed over 3 plus c. Guys, this is the time to not forget that plus c. Or should I say, this is not the time to forget the plus c. Whichever way makes more sense to you, whichever way resonates with you, understand that you cannot forget that plus c. Let's simplify. 24t minus 9t squared plus t cubed plus c. Okay, and that's obviously equal to x. All right, so now we need to work out what this plus c is, because it's got a value. It says initially the particle is at 0. So they're telling us information. They're telling us that at the beginning, in the beginning, x is equal to 0. Its displacement is equal to 0. So this means the when t equals 0, x equals 0. We know that. So we substitute 0 equals 24 lots of 0 minus 9 lots of 0 squared plus 0 cubed plus c. We do this in order that we be able to work out the value of c. In this case, everything comes out to be 0, so we get that c equals 0. So therefore, our expression for displacement is simply x equals 24t minus 9t squared plus t cubed. That's the answer to the first part of the question. Please, please, please do not trip. We have not finished the question. Find an expression for x at time t seconds. We've done that. Then show that when t equals t1, x equals 20, and find the value of x when t equals T2. Okay, so our T1 and T2 values are equal to 2 and 4, so we know this already. So T1 equals 2 and T2 equals 4. Okay, let me just see if I can go a bit lower. So we know that T1 equals 2 and T2 equals 4. Okay, so in here, when T equals T1, which is equal to 2, X equals 24 lots of 2 minus 9 lots of 2 squared plus 2 cubed. Please, I'm not going to try and stress myself. Let me just use the calculator. 24 lots of 2 minus 9 lots of 2 squared. And as I'm talking, I'm typing this in the calculator. 2 cubed. Great. Lo and behold, x equals 20. So that's the first part done. That's the first part proved. Then it asks us to work out the value of x when t equals t2. So when t equals t2, which equals 4, then we know x is going to be equal to 24 lots of 4 minus 9 lots of 4 squared plus 4 cubed. Again, those brackets is just me explicitly showing where I've replaced t with 4 in this case, or with the number that I'm substituting. Okay, this calculator is a bit dead. Just need to get a new one. Minus 9 lots of 4 squared plus 4 cubed. Please calculate it down me. And that's 16. X is equal to 16. That's it for this question, guys. Take care.